for a rigid body executing combined motion in a plane, okay, are the angular displacements of any two, see, it is combined motion, first of all, right? Combined motion means what?
Both
Right? So, both point A and point B will move.
Yes, sir.
And two particles with respect to are having combined means what? See, combined means what? B is rotating with respect to A, or A is rotating with respect to B.
Yes.
And now if you see this whole thing here, A is rotating with respect to B with omega, or B is rotating with respect to A with omega. Right?
Yes,
And it is also translating because it is combined motion. That means this point A will not be here. Even though it is in the center of the circle, it will also move. Hello, are you with me?
Yes.
Now be sensitive. See, you enjoy solving this problem. Your mindset will change. You will become very sensitive students. You will not see, you will observe. You will not hear, you will start listening. Right? And your brain will start now thinking. So you get a thinking brain. Right? So your metacognitive skills will definitely improve. Okay? So these are the outcomes of these things. Right? Examinations and all don't worry. Yes. So your brain power is increasing. Right. Now please try to answer this. Particles chosen. And rigid body is here. Are the angular displacements of any two particles constituting the rigid body are the angular displacements of any two particles? Angular displacement means, see, that time we saw
Theta
2 minus theta. Okay? Angular displacement of any two particles constituting constitutive body, the same with respect to any fixed point. Did you capture this problem first?
Yes, sir. Yes, sir.
So now B will go from this position to another position.
Yes, sir.
A will also go from this position to another position. That is, B will go from B to B dash, A will go from A to A dash. Right? And it's the combined motion. Right? So now B will go from B to B dash. So a line joining OB will now become OB dash.
OB dash. Yes, sir.
And the line joining OA will become OA dash. So if OB is making theta 1,
Yes,
then OB dash will become theta dash.
Theta dash.
Sorry, theta 1 dash.
Yeah.
And OA is theta 2 and OA dash will become theta 2 dash. Right? So now the question is the angular displacements of two particles constituting particle body the same with respect to any fixed point arbitrarily chosen in a certain interval of time.
Sir, it is rotating about point in B.
See, now don't ask me a counter question.
They are not told that.
They are not told. Reference point O is fixed. That is one thing. Right? That is one thing. So, see, now initially, say OB is making some angle, okay, and the line joining from O to A is making some angle. And now, say B will change from some angle by, say, some degrees theta. The line OB, when it becomes OB dash, it will become, the change will be theta, assume. And so simultaneously A will also change.
Yes.
So now the change in B, the angle made by OB with respect to OB dash, OB dash got made angles with OB. So the angle between those two is theta. So it takes theta, okay, and OA will now become OA dash. Now will this also be theta? Question.
It is.
So draw the diagram and see. So understand this problem carefully. So this is A and B. This is A and B. Okay, this is point O. So B now goes to some other point. Say this goes to B dash. B will now go to B dash. So this is the angle made. Right? So this angle is theta. B will go to B dash. Now A will also go to A dash. Okay. Now will the angle made by this line OA, when it becomes OA dash, will be same as the angular displacement of the point B. It's a combined motion. That means it is also rotating and it is also translating. So here the reference point is fixed. In the previous case, the reference line was fixed. So in the previous case, the line drawn to the object at two positions was making two angles with respect to the reference line at two different points on the reference line. Okay, shall I tell you? Hello? Hello? Are you there?
Yes, sir. Yes.
Okay. Now, see here. Hello, everybody, please pay attention. Stop doing.
Yes.
So now I said B is going from B to B dash. Okay. Now, A can go anywhere. A dash can be here or A dash can be here also. Isn't it? ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಏನಾಗೈತೆ ಗೊತ್ತಾ, ಅವ ಪಾಪ ಒಂದು ಸೀಸನ್ ನಾವು ಕೋಪರೇಟ್ ಮಾಡ್ತಿದ್ದ, ಅವ ಎಸ್ ಸರ್ ಈಗ ಒಂದು ಗಂಟ್ಲ ಹೋಗೈತಿ, ಅದಕ್ಕೆ ಬೇರೆದವ್ರಿಗೆ ಏನು ಇದೇ ಇಲ್ಲ. ಹಲೋ ಅನುಗಳು. ಸೊ ಎ ಡ್ಯಾಶ್ ಕ್ಯಾನ್ ಬಿ ಹಿಯರ್ ಆರ್ ಎನಿವೇರ್. Okay, supposing A dash is here, then B has gone to B dash, it has made angle theta, but then A will not make angle theta.
Yes.
So it is not possible. Or A can go to point A dash here, okay, and this angle can also be theta.
Yes, sir.
So it is not guaranteed that it will make it, the angular displacement will be same.
Yes, sir.
See, the question asked was, are the angular displacement of any two particles constituting the body the same with respect to any fixed point? Okay, that is omega A with respect to O is equal to omega B with respect to O. Is it possible? It may or may not be possible.
Yes.
It is combined quotient. Okay, got it? So you see, you should draw and estimate the things. So A can be here, A dash can be here, like that. Okay. Anyway, there is a beautiful diagram.
Sir, but doubts.
Sir, but the position of A is constrained by the angular velocity.
By the angular
Velocity.
Why? What is it? Why it is constrained? What is constraining it?
And the position of A cannot.
No. It is combined motion, gentlemen. So there is a velocity vector associated with A and B, horizontal. Or sorry, it can be in any direction, but there is a velocity vector, linear velocity vector, ma'am, associated with point A and B.
Yes.
Understand? That is not shown here.
Yes, point A is also moving.
Sijan, did you get it?
Yes.
Point A is also moving. That's what I said initially. Yes. Consider the possible position of body at a later instant as shown, and theta 1 is not equal to theta 2, and angular velocities are not equal. Clear?
Yes, sir.
Yes, sir. Yes, sir.
So working with the reference. In the above situation, if the body is in pure rotation about O,
Yes, sir.
Yes, sir.
then what can be said about omega, AO, BO and omega? Pure rotation about O. Not, see the diagram here.
Pure rotation.
Pure rotation about O.
Yes, sir.
It is pure rotation about O, not A.
Yes, sir.
A and B both.
It will connect with angular distribution.
Angular distribution.
So, will omega A with respect to O is equal to omega B with respect to O is equal to omega AB?
Yes, sir.
Yes, sir.
For pure rotation, yes, sir.
Pure rotation.
About O.
Yes, sir.
About
Yes,
O,
Yes, sir.
Yes,
Yes,
sir.
sir.
It will be.
it will be.
Yes.
Yes, sir. Yes.
Omega B with respect to A will always be equal to omega A with respect to B.
Omega.
Omega B with respect to A will always be equal to omega of A with respect to B.
Yes, sir. Yes, sir.
Okay, I said.
That is there. But only thing is, now the other condition must also be satisfied. What is that?
It should be equal to
Omega of, hey, omega of that body must also be equal to this.
Yes,
Yes.
sir.
Is it possible?
Sir, what is omega, sir?
Omega is the whole body is rotating. See, it is pure rotation, man.
That is also rotating and rotating.
In the above situation, if the body is in pure rotation about O,
Only about.
only about O,
There is no rotation in the body itself.
there is no rotation in the body. But the line AB, see, listen here. The line AB is rotating.
Yes, sir, it's rotating. About
Yes, yes, sir. Very good.
So take that into consideration. So here you have A and you have B and you have O. Okay. So now this body is rotating about O. This
Yes, sir.
body is rotating above O. Okay. So that is pure rotation above O.
Yes, sir.
Pure rotation above O means, so A will somewhere become say A dash here. Okay, and B will become B dash here.
Yes, sir.
Yes, sir.
Okay, and therefore this and this, so this will go by theta. Okay, and this will also go by theta.
Yes, sir.
Yes, sir.
Within pure
Yes, sir.
rotation. Okay, and so and this line. What is this line now?
Line
This
of
line, B is going to rotate with respect to A. So this is BA.
Yes.
And this will always be equal to omega A with respect to B.
Yes, sir.
Now this line OB. See, now the question is this line itself. Now this was the line here. Hello.
Yes, sir.
Now this line has
Yes,
now
sir.
become this line,
Yes, sir.
Yes, sir.
right?
Yes, sir.
So this line has become this line.
Yes, sir.
Okay. So this line now, this line has now become this. Is this also theta?
Yes, sir.
So this was AB. Now it is pure rotation. It has become this one. So is this also theta?
Yes.
Did you get understand what I have drawn here? If you are not understood, you ask.
You have drawn it.
Sir, did you
It
have
must be like this. You have drawn it.
What I have drawn? I have drawn here. See this B. This B has now become. This B is now B dash,
Yes, sir.
and
Yes.
A is now A dash.
Yes, sir.
So this line is now oriented like this.
Yes, sir.
So
Theta,
this line was like this.
if you are considering point A and
See,
point
this
B-
line was like this. Now this line has become like this.
Yes, sir.
What is your problem? This
That
line,
theta which you have drawn, that is.
how it should be?
You are telling with respect to A, no, sir. That line.
I am telling with respect to B. I am showing it with respect to B.
B
This line was like this. Now this line has become like this. So this angle is theta.
Sir,
Hmm.
how that fill in? Like previously you took a line parallel to BA, sir.
I didn't take anything parallel. I have drawn this line.
Yes, sir.
Huh.
That angle then however it is with respect to B, sir. It's not.
With respect to BLV, this line itself has now become this line.
Yes, sir.
So what is the angle made by this line now? Theta, no.
Okay, sir.
I don't know whether it's theta or not. Say I'll take it as theta dash.
With respect to what it was.
Hey, this line itself, with respect to this line, what is the angle of this line?
Right, sir.
Now, is this theta? The question is now, is this theta? And if these thetas are equal. So this one is. So this is omega of B with respect to A is equal to omega of A with respect to B, and is this also equal to omega of AB? Omega of AB means this.
It should be equal.
Yes, sir.
Yes, sir. Because
Prove.
all other particles.
Prove.
Mathematically.
With respect to A and B.
Yeah, okay. No, this is wrong. This attitude is hopeless.
And
How did you say it is not possible?
and
Don't start using your smartness, your supernatural skills and all here. You should use some law, concept, mathematical modeling, and then you should say yes or no. No intuition and all. That all in school it will work. Here you may make a mistake, you will get negative marks and you are out of the race. Don't develop this attitude. So you have to do some mathematics and you have to prove that.
Sir.
Understood? B has, okay, all of you pay attention. Pure rotation. So B has moved from here to B dash. A has moved.
Yes.
So A has moved from here to A dash because it is pure
Yes.
rotation. Okay. And as you know, this angle theta will be same. There is no doubt about this. That is omega of B with respect to O must be equal to omega of A with respect to O. No doubt about this.
Yes. Yes, sir.
Now the question is omega AB. That you have to prove it is equal to this. Omega AB means what now? This angle. See, this line was like this. Now this line was like this. Now this line has become like this. So this angle should also be equal to theta. That is what we have to prove. Okay? Anyway, you can prove it, but at least you understood now. You have to prove that, and it can be
Yes,
proved.
sir.
This is it. So BA is perpendicular to RA. RA means what? The line drawn from origin to A.
Yes.
Sir.
And VB is perpendicular to RB.
Yes.
Hello?
Yes, sir.
Understand now? So this line, this is always perpendicular to this.
Yes.
Okay? And so therefore VA with respect to O is equal to omega of B with respect to O. Okay? Now VA is equal to omega O cross array.
Yes, sir.
Yes, sir. Yes. Yes.
And VB is equal to omega O with respect to RB because the body itself is rotating with respect to omega about the point O.
Oh, yes, sir.
Yes, sir.
Okay. So then VB minus VA is equal to omega into RB minus RA. Right? So VBA is equal to omega naught RBA. But VBA is equal to omega BA into RBA. Now, if you compare these two, you will get omega naught is equal to omega naught is equal to omega B with respect to A. Therefore, this is equal to this.
Yes, sir. Yes.
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 Got it?
Yes.
Huh?
Yes, sir.
Anyway, these are all small steps here. Okay. So the abstraction is here. Note, for a rigid body in pure rotation about fixed point, every particle rotates about the fixed point at the same angular velocity as the angular velocity of the body. But remember here, see, I have given you different cases now. The previous one was a case where the body is has combined motion
Combined motion.
with respect to a reference line.
Yes, sir.
Now this is with respect to a reference point. Now don't confuse that and this.
Yes, sir.
Yes, sir.
Okay, so that means now any line on the object which is in pure rotation, not see within itself it is in pure rotation. So omega B with respect to A will always be equal to omega A with respect to B. There is no doubt about that. Okay? But now here you see with respect to this, whatever the entire body is having omega naught. The body itself is having omega naught. Right?
Yes.
The body itself is having omega naught. And it is pure rotation of the body.
Yes, sir.
Right? So if you have drawn some line inside it, okay, that line is also rotating as it is performing pure rotation like this. See my hand, pure rotation with respect to this. Got it?
Yes.
Yes, sir.
Fine.
Yes, sir.
So now you see, we will slowly and steadily go into the complications. Okay, more and more complications of this. Wait, every time this is coming.